All right, today we're going to start Unit 2. And so first thing we want to do is refresh our memories on how to graph an equation. Because next we're going to be doing solving systems of equations. So we've got to be able to solve a regular equation first. So what we need to do when we're given an equation is we need to get it in slope-intercept form. And remember that slope-intercept form is that y equals mx plus b equation that we have seen so much, where we know that m is our slope and we know that b is the y-intercept. Now we know that the first thing we have to graph is the y-intercept. Then from the y-intercept, we can then count the slope. But we have to start with the y-intercept. So if I want to take this equation and get it in slope-intercept form, that basically means solve for y. So the first thing that I want to do is to move the x over to the other side. Well, in order to move this x, I'm going to subtract 5x. And then over here, I'm going to subtract 5x. Now, when I do that, the 5x's cancel, leaving me with 2y equals. And I know that I can't combine 6 and 5x because one has a variable, one doesn't, so they're not like terms. I like to put my x term in front, and that 5x is negative 5x, and my 6 is positive, so that's plus 6. So my y is almost by itself. I still need to get rid of the 2, so I'm going to divide everything by 2. So that would give me y equals, and then negative 5 over 2 does not simplify, so we're going to leave that as negative 5 over 2x, and then positive 6 divided by 2 is a positive 3. Now we have it in slope-intercept form. Therefore, we can determine that our y-intercept is the constant. So that's going to be 0, 3. So we're going to start with that on our graph. Then from that point, we can then count the slope, which is negative 5 over 2. Now, because the 5 is negative, that means we're going to count down 5, and the 2 is positive, so we're going to count right 2. So from our y-intercept on our graph, we're going to count down 1, 2, 3, 4, 5, and then right 2. And we have our next point. And then as we discussed before, we can continue to do that over and over and over. So 1, 2, 3, 4, 5, 1, 2. And once I run out of room, go back to my y-intercept and go backwards. I'm going to go up 1, 2, 3, 4, 5, 1, 2. And so then there is our line once we connect our dots. That's not a very good line, but you get the idea. All right, so we had that equation graphed, and that's really all we needed to do. So let's take a look at one more. So for this one, we also want to get it into slope-intercept form, meaning solve for y. So the first thing that I want to do is move that x term over. Well, since it's a negative 2x, I'm going to add 2x. And then I'm also going to add 2x over here. So my 2x's cancel, leaving me with 3y equals, and again, negative 9 and positive 2x cannot combine. One has a variable, one doesn't. I want to put my x first. My 2x is a positive 2x, and my 9 is negative 9. Then the last thing I need to do to get y by itself is divide everything by 3, which would then give me y equals 2 over 3x, because 2 over 3 doesn't simplify, and then negative 9 divided by 3 is a negative 3. So we can see that our y-intercept is going to be 0, negative 3. And we can put that on our graph, so negative 3 on the y-axis. And then from that, we can count our slope, which is the number in front of x, which is positive 2 over 3. So because this is positive, that means we're counting up 2, and then the 3 is positive, so that's right 3. So from our y-intercept, we count up 2, and then right 3. And we're going to do that again, up 2, right 3. And we're going to do that as many times as we can until we run out of room. Then go back to your y-intercept and go backwards. Down 2, 1, 2, left 3. Down 2, left 3, and down 2, left 3. And then we connect our points, and we have our line. Okay, so that's our quick review over graphing lines. Now we want to go ahead and take a look at our notes. So for our notes, we're going to be solving systems using tables and graphs, which is why we wanted to review how to graph lines. So we need to remember that we're going to be taking these equations, and if they're not given to us with y equals, then we need to get it to be y equals. So the first thing we're going to want to do is solve for y, so that we get an equation that is in the form of y equals mx plus b. That way we can get our y-intercept and our slope, and we can get the line graphed. Now, when we graph our equations, we're going to have 2 equations that we graph for each problem. And then once we graph these, we're going to see one of these 3 situations. We're either going to have intersecting lines, and if you have intersecting lines, then the solution for that system is going to be where those 2 lines intersect. So wherever they cross, whatever the coordinates for that point are, that's going to be your one solution. So if you have 2 lines that intersect, giving you one solution, we call that a consistent independent system. The second possibility is going to be when you graph them, they end up being the same line. So we graph one, and then you come back and graph the other one and realize it's the exact same line. So that's what we call coinciding lines, meaning they're the same line. And so then if they're the exact same line, then that means every point on the line is a point on the other line. Therefore, you're going to have infinitely many solutions. Every point on those lines will be a solution to the system because every point is on both lines. When that happens, we call that a consistent dependent system. The last possibility we have is when we have 2 lines that are perfectly parallel. They will never, ever, ever cross. Well, if the solution is where the lines cross, but these 2 lines don't cross because they're parallel, then that means that I have no solution. And I call that an inconsistent system. Now you can kind of tell ahead of time what's going to happen. So if you have intersecting lines, then those lines are going to have different slopes. So if they have different slopes, then they're going to cross at some point. If you go out far enough, they will cross somewhere. Then coinciding lines, so if they're the same line, then they're going to have the same slope, and they're going to have the same y-intercept. If you have parallel lines, they're going to have the same slope. However, they're going to have different y-intercepts. So once you get those lines in slope-intercept form, that y equals mx plus b, you can kind of tell right there what you're going to have, but you're still going to be asked to graph. So let's take a look at a problem. All right, so the first thing we want to do is to get these equations in slope-intercept form, y equals mx plus b. And I'm going to color code these. So I'm going to make my first one pink and my second one blue. All right, so I'm going to take that pink equation, which is negative 3x plus 2y equals 4. And if I want to get y by itself, I know the first thing I have to do is move my x. Since that's a negative 3x, I'm going to add 3x to get rid of it. Same thing over here. And then when I do that, the 3x's cancel. I'm left with 2y equals, I'm going to put my x term first, so positive 3x, followed by a positive 4. Then I need to get rid of the 2 in front of the y. So that's going to give me y equals 3 over 2 does not simplify, so we have 3 over 2x, and then 4 over 2 becomes plus 2. So that tells me that I have a y-intercept of positive 2. So that's going to be 0, 2. So I'm going to go to the y-axis and put that on my graph. Then from that point, I can count the slope, which is whatever's in front of x, so 3 over 2. So since that 3 is positive, that's up 3, and the 2 is positive, so that's right 2. So up 3, right 2, up 3, right 2, or I can go backwards, down 3, left 2, down 3, left 2, and over and over and over. All right, so there is my first line. Now remember, I have 2 lines though. So I need to graph both lines and see where they intersect, if they intersect. So then I take my second equation, x plus y equals -8. Now this one's a little bit easier to get y by itself because all I have to do is move that x. Since it's a positive x, I'm going to subtract x to move it over. And so then that's going to give us y equals, now I have a negative x and then a -8, so -8. So y is already by itself now. My y-intercept is going to be that number without a variable, so 0, -8. So we can go ahead and put that on here. 1, 2, 3, 4, 5, 6, 7, 8. And then from that point, I can count my slope, which is, remember, this is an understood 1 in front. Therefore, my slope is -1. Now, I'm going to put that over 1 to make it a fraction because I need a fraction to count my slope. Since the top number is -1, that's down, and the bottom is +1, so that's to the right. So from my y-intercept, I'm going to count down 1, right 1, and then I'm already out of room. So I'm going to go from the y-intercept, up 1, left 1, and then I can continue that over and over and over again. Then I connect my dots, and I get my second line. Now your solution is where those lines intersect. So it intersects right here, and the coordinates for that would be 1, 2, 3, 4, so -4, and then down 1, 2, 3, 4, -4. So the coordinates for that point would be -4, -4, so that is your solution, -4, -4. Now what that means is that if you take your x value and your y value and you plug it back into either one of these equations, you should get a true statement. So if you plug in for x and y here and you do your math, you should get 4. If you plug in your x and your y here and you do the math, you should get -8. So that's what your solution is. Now, we need to talk about whether it is consistent independent, consistent dependent, or inconsistent. So we have 2 lines that intersect. Therefore, we have a consistent independent system. So consistent independent. So you are asked to not only solve the system, but to classify the solution as consistent dependent, consistent independent, or inconsistent. Alrighty, so let's take a look at number 2. So again, I'm going to color code pink and blue, and I'm going to take each one of those equations and I'm going to get it in slope-intercept form. Well, I notice the first equation, y equals 2x plus 4, is already in slope-intercept form because y is by itself, which means I don't have to change this one. I can already see that my y-intercept is that number that does not have a variable attached, +4. So 0, +4. So if I put that on my graph, 1, 2, 3, 4. So positive 4 on the y-axis. And then from that point, I count my slope, which is 2. And then I'm going to put that over 1. So positive 2 is up, positive 1 is to the right. So from my y-intercept, I count up to right 1, and then I do that over and over. And once I can't do it anymore, then I'm going to go down 2, left 1, and I'm going to do that as many times as I can. So there is my first line. Now I need to do my second line. So I have 4x minus 2y equals 8. First thing I need to do is get rid of that 4x, which leaves me with a negative 2y. And then I want my x term first. Well, 4x is negative, and 8 is positive. Now I can get rid of that negative 2 by dividing everything by negative 2. And that gives me y equals negative 4 divided by negative 2 is a positive 2x. And then 8 divided by negative 2 is a negative 4. Well, look, this is almost the same line, but not quite. The slopes are the same, but the y-intercept is different. So think back to those original 3 possibilities we had, and that's one of the ones that we talked about. So this one has a y-intercept of negative 4. 1, 2, 3, 4. So my y-intercept is 0, negative 4. And my slope is 2, and we put that over 1. So again, up 2, right 1. So 1, 2, 1, 2, 1. And so I do that over and over and over again. And I notice my slopes are exactly the same, which means that these lines will never, ever, ever cross. They are parallel. Therefore, I have no solution. And no solution, when you have parallel lines, is going to be an inconsistent system. All right, so now we need to take a look at number 3. But make sure you always list the solution and whether it's consistent independent, consistent dependent, or inconsistent. And I left my n out right here. Okay, so for number 3, again, we have 2 equations, pink and blue. We take that first equation and we see again, we already have that in slope-intercept form, which is nice. So the y-intercept is going to be negative 1. So we write that as 0, comma, negative 1. So negative 1 on the y-axis. Then from that point, we count our slope, which is positive 1/2. So since it's positive 1, that's up. Positive 2 is to the right. So from my y-intercept, I go up 1, right 2, and I do that over and over and over again. Then once I run out of room, I go back to that original point, and I go down 1, left 2, and do that over and over again. So then I have my first line right there. Now I want to take my second line, which is negative 2x plus 4y equals negative 4. This one is not in slope-intercept form, so I need to solve for y. So I need to get rid of that x first. Since it's negative 2x, that means I need to add 2x to cancel it out. And then those are gone, leaving me with a positive 4y equals, put your x term first, so I have positive 2x, and I have a negative 4. Then I can get rid of the 4 by dividing everything by 4. And that gives me y equals. Now, if we take a look by the x, we have 2 over 4. That's a fraction, and it can be simplified. So both of those numbers can be divided by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So 2 over 4 simplifies to 1 over 2. Don't forget the x on there because that is the slope. And then negative 4 divided by 4 is a negative 1. Well, look at this. This is the exact same line as this, which means when we graph it, we're going to get the exact same points and the exact same line. So we have a y-intercept of 0, negative 1, because of this negative 1. So our y-intercept is right there, where the other one was. And then our slope is 1 over 2, just like the other one. So up 1, right 2. So all of these points are going to be exactly the same, which means when we connect them, the lines are going to be exactly the same. So because the lines are exactly the same, that means every point on these lines is shared. Therefore, every point on the line is a solution, which is why we have infinitely infinitely many solutions. Or sometimes you'll just hear people say IMS, infinitely many solutions. Now, infinitely many solutions, if we look back, when we had the same line, infinitely many solutions meant we had a consistent dependent system. So we're going to put consistent dependent. All right, so we have our solution and we have our classification of the system. All righty, let's take a look at some word problems. Now that we've seen an example of each type of those, we want to see how systems can be represented in real-world situations. So we're going to solve using a table of values. Now it says the diagrams show the birth lengths and growth rates of 2 species of shark. If the growth rates stay the same, at what age would a spiny dogfish and a Greenland shark be the same length? So we're looking for how long is it going to take for them to grow to be the same length. They're not going to start the same length, but eventually they will get to be the same length. How long is that going to take? That's what we're trying to find out. Now we can write an equation for this because we can see down here that it is a constant growth rate for each one. So constant growth rate means linear. So we're going to write our equations as y equals mx plus b. So m is going to be our rate, in this case our growth rate, and then b is the starting amount. In this case, it's going to be the length at birth because that's when their life starts, is at birth. So our m is the growth rate and our b is the birth length. So we can write an equation for each one of those. So if I want to write an equation for the growth of a Greenland shark, so Greenland shark is here, then that's going to be y equals, well, we said m is 0.75. Don't forget your x. And then plus b, the beginning amount, our birth length is 37 centimeters. So we have an equation for the Greenland shark. Now write an equation for the spiny dogfish shark. So our growth rate is 1.5 centimeters per year. So y equals 1.5x plus our b, which is 22 centimeters. So we have an equation for each one. Now that we have the equation, we're able to fill in this table and we can figure out how long it would take for those sharks to be the same length. So let's rewrite our equations. The Greenland shark was y equals 0.75 x plus 37. And then the spiny dogfish shark was y equals 1.5 x plus 22. Now, we've been given some values for x to plug in, and that's great. If we're not, we can just choose some and just go until we find one that works. But what we're looking for is in one of these years, these two amounts will be the same. So we need to figure out which year will these two amounts be the same. That's what we're looking for. So if we take 17, because that's our first x value, and we plug that in for x, so then 0.75 times 17, and then plus 37, you can use a calculator for this, would give you 49.75. Okay, let's go ahead and take 17 and plug it in here. Because if they're the same at 17, I don't really need to go any further. So if I take 17 and I plug it into my second equation, that's 1.5 times 17 plus 22, and that's going to give us 47.5. And these are measured in centimeters. This is the length of our shark. Okay, well, they're not the same length at 17 years, so let's try 18. So if I plug 18 into the first equation for x, then that's 0.75 times 18, then plus 37. That gives us 50.5 centimeters. All right, let's do our second equation then. If I plug 18 into the second equation, 1.5 times 18, then plus 22 is going to give us 49 centimeters. Nope, not the same yet either. So let's go on to our next one. 19. So now I want to plug 19 into each equation. So in the first equation, 0.75 times 19 plus 37 is going to give us 51.25 centimeters. Then take 19, plug it into the second equation. 1.5 times 19 plus 22 would give us 50.5 centimeters. So we're getting really close, but we're still not the same. We need to be exactly the same. So next we're going to take 20. Plug 20 into the first equation. 0.75 times 20, then add 37. We get 52 centimeters. Then we're going to take 20, plug it into the second equation. 1.5 times 20, and then plus 22 is going to give us 52 centimeters. What do you know? That's the same. Now, if that hadn't been the same, then we would continue on, and we would do 21 next. Then if that wasn't the same, then we would do 22. And we would keep going until we found one that both equations came out with the same number. So because both equations come out to the same answer at 20 years, that means that it takes 20 years for those sharks to be the same length. Alrighty, so that is how we will write equations and then use that to solve a real world type problem. All right, so next you guys are going to want to get into your practice, make sure that you do all those problems, check your answers, and then get that submitted on Canvas.